Hello class, today we're going over lesson 7.4, how to find distance in the coordinate plane. So let's start off with our definition here. Remember guys, this is our last section from chapter 7, so it's going to be a little bit of a challenging one and need to make sure you guys are getting all your notes down here. All right, so our first definition is that of a coordinate plane. So hopefully this is something you've seen before, but if not, a coordinate plane is a two-dimensional plane made by the intersection of an x and y axis. We use this plane to map coordinates and draw figures. So basically, if we're looking at our coordinate plane here, it's basically one number line going horizontal, which we call the x-axis, and one number line going vertical, which we call the y-axis. So just two number lines stacked up on top of each other like a T, like this. So obviously on a number line, the positive numbers are going to be the right. So on a horizontal one, they're going to the right. Or on the x-axis, our positive numbers are going to the right. On the y-axis, or our vertical one, our positive numbers are going up. So that means that in quadrant 1 over here, this is going to be all positive numbers. You're going to have two positive numbers. In quadrant 2, since that's to the left of the number line that's horizontal, then you're going to have a negative x coordinate and a positive y coordinate. In quadrant 3, which is this one down here in the bottom left, notice how we're negative on both the x and y axis. So that would mean that over here we have both negative points. And then finally in quadrant 4, it's positive on the x-axis because we're to the right, and negative on the y-axis, so we'd be down here. All right, so our goal today is we are going to apply the Pythagorean theorem to find the distance between 2 points on a map. Okay, so let's start with this one here. We want to find the distance between the 2 points. So how are we going to use Pythagorean theorems here? Well, what we're basically going to do is we're going to draw ourselves a triangle connecting these points right here. So if I draw myself a right triangle, notice how we got that right angle right here, right? So I see a right triangle. Well, what do we need to know to use Pythagorean theorems on a right triangle? We're going to need to know our side lengths here. So this side length from B to the corner here, we're going to have to count it. So the way you count it is you start at B, and you're going to make yourselves little loops and stop on every single different number here. So for example, this would be 1, and then 2, because I have 1, 2 jumps. So the distance here is 2. What I don't want you guys to do is start here, say 1, and then go 2, and then 3. That's not how you count this here. You start at 0, and then you go to 1 when you move. Just like when you're taking a step, you don't say 1 before you take your first step. You say 1 as you take that step. Okay, so we got one distance here, and then from this point up to A, 1. So this distance here is 1. So that means I have a triangle with A is equal to 1, B is equal to 2. And now we have to plug this into Pythagorean's theorem. So I have 1 squared plus 2 squared. 1 squared is 1. 2 squared is 4. 4 plus 1 is 5. Remember, this is all equal to c squared, right? But we don't want to know what c squared is equal to. We want to know what c was equal to. So we got to take the square root of both sides here. And that means that c will be equal to approximately 2.2. All right, again, we just used Pythagorean theorem there. And the main thing we had to do was count our distances on these points. All right, make sure you guys are getting this one down in your notes here. I would draw the picture as well, just so you have something to look at next to this one here. But let's move on to our next problem. So we want to find the distance between these 2 points here. So again, let's start off by drawing a triangle. We have our B to the corner point here, and then from A down to meet there. And then lastly, we just need to connect A and B. Alrighty, so here's our right angle here. Now we got to find our side lengths. So from B to the right angle, we have to make 1 jump. So this distance right here is 1. From A to the right angle, we have to make 1, 2, 3, 4 jumps. So this distance right here is going to be 4 because we have 1, 2, 3, 4 jumps. So I have an A is equal to 4, a B is equal to 1. Now let's plug them into our equation here. So we're going to have A squared plus B squared is equal to C squared, which means 4 squared plus 1 squared is equal to c squared, which means 16 plus 1 is equal to c squared. 17 is equal to c squared. Now remember, we've got to take the square root of both sides here because we don't want to know what c squared is equal to. We want to know what c is equal to, and that means that c is approximately 4.1, which means this distance right here is approximately 4.1. Think about it, because we got 1, 2, 3, 4 jumps there, so that makes sense, and then the little extra distance by going diagonal there. Alrighty, everybody, so that was our second one there. Again, I would try to at least draw the picture. That way you can kind of see what's going on with these jumps, and then also make sure you have this worked down as well. Got a couple more examples for you here, and then I'll let you go. All right, plot the points 2, 5, and 3, 3, and find the distance between them. All right, so the way we plot our points is we basically just have to line up with these coordinates here. So on an x, y coordinates, your first coordinate is your x, and your second coordinate is your y. So to plot a point here, if it says x2, then we're going to go over to where 2 is here. So we have to be lined up with where 2 is here. Now it says y is equal to 5, so we got to line up where 5 is here. So if we're going over 1, 2, and up 1, 2, 3, 4, 5, then that means that our first point is going to be right here at 2, 5. Where you're just lining up the x and the y points there. Alrighty, so for the next one, it's 3, 3. So our x is 3, our y is also 3, which means we need to be at the intersection of these 2 points, which is right here. All right, so we got 2 points on our graph now. Now we just got to connect them using our lines here. So we'll draw a line down, draw a line across, and lastly, we're going to make our hypotenuse. There we go. So there's our right angle. So let's call this point A and this point B here. So the point from B to the right angle looks like we have to make 1 hop. So this distance here is 1. From our A to the right angle, we have to make 2 hops. So this distance here is 2. Well, this question looks a little bit familiar now. All right, so our A is equal to 2. Our B is equal to 1. So 2 squared plus 1 squared is equal to c squared. 4 plus 1 is equal to c squared. 5 is equal to c squared. Now we have to take the square root of both sides. We're going to get c is approximately, that's similar to the one we did before, I should remember this. C is approximately 2.2. Alrighty, guys, so that's the last one here with a coordinate plane on it. Remember, all we're doing on the coordinate planes is we need to count the distance between the 2 points, and then we'll use Pythagorean's theorem to find the distance of the hypotenuse there. Remember, that is the distance between those 2 points. All right, so let's do one example here, but a little bit of a real-life one. Suppose a park is located 3.6 miles east of your home. The library is 4.8 miles north of the park. What is the short distance between your home and the library? All right, well, let's start off by drawing ourselves a little house here. We'll call this our home. Oh, gosh. It's a terrible drawing, but it's good enough. Okay, so it says a park is located 3.6 miles east of our home. So east kind of just means to the left. If you guys don't know your northeast, south, and wests, never eat soggy waffles. I feel like that's wrong. That's backwards. What east should be over here. Whatever. Whatever. It's hypothetical in this one anyway, so it won't make too much of a difference. So we're doing east of our home here, so we're going to the left. This right here, we're going to make a big point. We're going to put a little P there. This is our park. Okay? So this right here, remember, it tells us this is 3.6 miles from our home. All right, so the next one, the library is 4.8 miles north of the park. So what is the shortest distance between our home and our library? All right, so we got to go 4.8 miles up from here. Do that right here. And we're calling this point an L for library, right? All right, so it wants us to find out what is the shortest distance from the home to the library. So this line right here, what is that shortest distance? All right, and it says this is a 4.8 here. So look at this, guys. Look, we have a right triangle. Surprising. We're doing the same thing that we've done in every single section here. Big shock, right? All right, so we got to plug it into our Pythagorean theorem here. Let's call A equal to 4.8 and B equal to 3.6. Remember, it doesn't matter which one of these is A and which one is B, as long as both of these are A. Or excuse me, both of these are not C. So we have A squared plus B squared is equal to C squared. We got 4.8 squared plus 3.6 squared is equal to C squared. Now, 4.8 squared is equal to 23.04. 3.6 squared is equal to 12.96. Still equal to C squared. So we got to add these two together here. And we are going to get 36 is equal to C squared. Now, if we take the square root of both sides here, then we're going to get C is equal to 6. Alrighty, everybody. So make sure you're getting this down here. I would at least draw yourself some sort of picture so you can kind of see what's going on while also writing this work here. All right, class. So in conclusion, today we found distances in the coordinate plane. Make sure you guys are taking notes on this, also writing a 2-sentence conclusion so I can give you a stamp on that notebook. All righty, everybody. I will see you in class tomorrow. Have a great rest of your day. Peace out, y'all.